So every time you see this, just know that you have 3 marks. So the velocity v meters per second of a particle moving in a straight line at time t seconds is given by v is equal to 3t squared minus 2t plus 2. When t is equal to 0, the particle is 3 meters from a fixed point O on the line. So in short, this thing is passing through some point where t is 0 and then distance is equal to 3, which is 0,3. So you should keep this one somewhere. So find the acceleration when t is equal to 1.5. So let me just to find the acceleration, we can simply differentiate this with respect to x. So v is equal to 3t squared minus 2t plus 2. Remember, acceleration is equal to the change in velocity with respect to time. You normally just say v final minus v initial over time in physics. So it's the same thing here, except that this change is said to be dv, and then the change in time is said to be dt. So once I differentiate this with respect to t, I'll get my acceleration. So when I differentiate this, I get 6t. I differentiate this, I get 2. And then I differentiate that, I get a 0. So now I want the acceleration when t is equal to 1.5. So this is what we want. You can say 6, 1.5 minus 2. Then this times this will give us a 9 minus 2. So this minus this will give us a 7. So that's our acceleration when t is equal to 1.5. And then an expression in terms of t for its distance from a fixed point. I think that fixed point should be O, this one here. So to find that formula, that expression, you can simply say velocity is equal to 3t squared minus 2t plus 2. So we are trying to find an expression for distance. So we have distance. Once you differentiate distance or you divide it by time, you get the velocity. You divide this by time, you get the acceleration. So in this direction, you are differentiating. And then to move backwards, you have to integrate. Yes, so in this case, we have the velocity, we want the distance function. So we can just integrate this to get to that. So distance will be the integral of this. And since it's a polynomial, you must put it in brackets. So now let's integrate. My pen is dying. So when you integrate this with respect to x, you have 3t to the power 3, and then over 3. And then you integrate this, you have 2 squared over 2. You integrate that, you have a 2 and a t, and then plus c. So now you just want an expression, but then this c has to be taken care of. So remember what we said, this particle is 3 meters from a fixed point O on the line. So that means it is passing through 0,3. In short, when the time is 0, remember this is like the origin, our c or our distance, which is s, is m. Remember, the starting point is said to be 0, so which explains why we have this. So in short, our c is equal to 3. If you want to solve it, you can just substitute the numbers. Where you have an S, you can put your 3. Where you have T's, you can just put zeros. I'm not writing these numbers because this is a 0 anyway. So as you can see, our C is equal to 3. So that means our S is given by 3 over 3 is still 3. So we have t to the power 3. 2 over 2 is still 2. So we have t squared plus 2t, and then plus our C, which is a 3. So this is the expression in terms of t which they are looking for. And then on part C, we want to find the distance between T1 and T2. So we have the distance formula here. We can simply find our T of 1 and T of 2 and then find the difference between the two. So our S of 1, this is easy. This part here will be a 1, this one will also be a 1, this will be a 2, this will be a 3. I'm just substituting ones there. So whether I cube it or I square it, it will still be a 1. So S of 1 will be this minus this is 0, this plus this is 5. And then our S of 2, I can substitute my 2's in there. So you can say 2 to the power 3 minus 2 squared plus 2 and then times 2 plus 3. And then this one will be our 8, this will be 4, then this will also be 4, this will be 3. So negative 4 plus 4 is 0, so you can just say 8 plus 3, which is 11. So that means the distance between T1 and T2 is S2 minus S1. So this one will be 11 minus our S1 is 5. So this gives us a 6 meters.